Okay, I asked you to do two others on page 171. Number 11 says, pushing a grocery cart with a force of magnitude 95 newtons applied at an angle of 35 degrees downward from the horizontal. So going this way. Okay, so the force here is 95 newtons. And the angle with the horizontal is 35 degrees. This is Fx, this is Fy. And the question says, makes the cart travel at a constant speed, so that means Ax is 0. Of course, there's an Fg acting down, an Fn acting up, friction acting backward. And so the question says, what is the frictional force acting on the cart? Okay, so if we do look at just the x direction, sum of the forces is equal to max. Ax is 0, so max goes to 0, which means it's Fx minus friction is equal to 0. So the frictional force acting on the cart is just the x component. And so we can find the x component, it's the adjacent side. So cos theta is equal to Fx over F. So Fx is equal to F cos theta. So Fx is equal to 95 newtons times the cos of 35. So Fx equals, sadly I don't know the cos of 35 in my head, times 95. 77.819 newtons. That's Fx, which means it's also friction. So 77.819, and there's several 4s after it. Okay, so that is number 11. Number 12 says, a man walking with the aid of a cane approaches a skateboard mass of 3.5 kilograms lying on the sidewalk, pushing with an angle of 60 degrees down from the horizontal. So again, here's my skateboard, and he's pushing at an angle of 60 degrees. So this in here is 60 degrees. Downward with the horizontal, he applies a force of 115 newtons, and the skateboard was 3.5 kilograms. So there's an Fy, there's an Fx. So the question wants to, it says, which is enough to roll the skateboard out of his way. Calculate the horizontal force acting on the skateboard. In other words, find Fx. So again, it's the adjacent side, so it's cos. So cos theta is equal to Fx over F. So Fx is equal to F cos theta. So Fx equals 115 newtons times the cos of 60. Cos of 60 is a half. So this is 57.5 newtons. Okay. The second part of the question says, calculate the initial acceleration of the skateboard. So we have to assume there's no friction. Why? Because it doesn't say anything at all about friction. Skateboard wheels roll, and rolling friction is usually the tiniest. There's several forms of kinetic friction, sliding and rolling. Rolling's the smallest of all the types of kinetic friction. It's why our tires roll when we drive. You don't want them to slide. Okay, and so if we do the sum of the forces in the x direction is equal to max, the only force then is Fx. And we're solving for A, so Ax is just equal to Fx over m. So 57.5 newtons over 3.5 kilograms. Yeah, I guess that is enough force to roll it out of the way. This is going to be a huge acceleration, 16.4286 meters per second squared. Don't mess with a guy with a cane, I think is the moral of the story. Okay, I didn't assign number 13 just because I thought I had given you enough, but you can certainly do it. It's not that you couldn't do it. So maybe because there's a few minutes left here, if you want to stop the video and try it, and then turn the video back on. A mountain bike with a mass of 13.5 kilograms. 13.5 kilograms. Oh, and a rider of, I should keep reading, and a rider, I'm going to make this a little bigger, of mass 63.5 kilograms, so for a grand total of 77 kilograms, is traveling at 32 kilometers per hour, VI, 32 kilometers per hour. When the rider applies the brakes, locking the wheels, how far does the bike travel before coming to a stop? VF is 0. And it's looking for a delta D. When you apply the brakes, the only force backward is the braking force, or the force that friction is putting on your brake pads. FG will be acting down, FN will be acting up. Coefficient of friction is 0.6. Okay, so the first step would be sum of the forces in the y direction to get your Fn. It's not moving in the y, so Fn minus Fg will equal 0. So Fn will equal Fg will equal mg. So 13, it really is 13.5 and 63.5. 77 kilograms times 9.81 meters per second squared will give you an Fn of 755.37 newtons. Once you have that, you can get your friction. FFR is equal to mu Fn, so 0.6 times 755.37 newtons. So friction will be equal to 42,453.222 maybe newtons friction. So then you do sum of the forces in the x direction. And in the x direction, the only force is the braking force, and it's acting backward. Okay, and that's equal to MAX. So AX will be equal to negative friction, because that friction and the braking force are the same thing, divided by M. Okay, so maybe I need to go back and explain. When you put your brakes on, what brings you to a stop is friction, right? Because when your tires stop rolling and now they begin to to slide, and friction will bring you to a halt. Okay, and so negative 453.222 newtons over 77 kilograms. AX is equal to 5.886 meters per second squared. And now once you have this, now you go to your VF squared equation. VF squared is equal to VI squared plus 2A delta D. So delta D will be equal to VF squared minus VI squared over 2A. The VF goes to 0. Delta D is equal to negative VI squared over 2 times, oh, I lost my negative, negative 5.886 meters per second squared. I left a blank there for the speed because it's 32 kilometers per hour, so you need to change that to meters per second. Okay, so 32 divided by 3.6 gives you 8.8 repeating, and then square it. Meters per second, square it, divided by 2 times 5.886 with the negative, and you get a delta D, I believe, of 6.71188 meters, and the two negatives cancel each other out. Okay? All right, there you go.